Good morning. It is Tuesday, May 5th. This is day 3, lesson 2 of I can graph sinusoidal models using amp, sine, freq, x, shift, and drawing a little picture. So we're going to say lesson 2. I gave you 2 days to work on the first part. And basically, it's the same thing that we've been doing, amp, sine, freq, x, shift. And it's very helpful to draw a little picture which will contain the midline, min, max on the y-axis, and the period on your x-axis to give you structure. So we did 1 and 2. I asked you to try 3 and 4. So we're going to go over 3 and 4. I'm going to go over a couple more, and we're going to go from there. Let's go purple. All right. I have this. The hottest day of the year in Santiago, Chile, on average is January 7th, when the average high temperature is 30 degrees Celsius. So let's stop right there. The high is 30. So when I make my little picture, my high, my max, is going to be 30. 6 months later, the coolest day of the year has an average high temperature of 14. So again, that 30 was the hottest day. Now, the coolest day is 14. That's going to be my min. Use a trigonometric function to model the temperature T months since January 7th. So, January 7th was the hottest day. So that means it's starting at the hottest day. It said 6 months later it was at its coolest. So that means that this is going to be times 0. This is going to be times 6, which means the period is going to be double that, which is 12. Because it starts at the max, it's got to be a cosine. So it's going to look something like this. I have my min, I have my max, I need my midline. Midline is min plus max over 2. That's 14 plus 30 over 2. That's 44 over 2, which is 22. So now I can go to my graph. I'm going to make each box on my y-axis worth 2. So it's going to be 4, 8, 12, 16, 20, 24, 28, 32. So even though each box is worth 2, I'm labeling every other box just to keep it a little bit neater. On my x-axis, I make my 4 dashes. 1, 2, 3, 4. Again, it doesn't matter how far apart they are. My period must go at the end of the 4th dash. My period is 12. Again, my period is 12. Since it said it took 6 months to get from the high to the low, that's half of the wave. So the other half must be another 6, which gives me 12. My midline is at 22. My max is at 30. My min is at 14. It's a positive cosine since it said it started at its max. So it starts at the max, then it goes midline, then it goes min, then it goes midline, and then it goes max. There's the graph. By the way, if you want to fill in these dashes, which you don't have to, you would just do the period divided by 4. since there's 4 dashes. So that's 3, 6, 9, 12. Again, you don't have to fill in those. You have to put at least one value on, which we generally do at the period. Okay, now that I have that, I want to write the equation. Y equals amp sign freak X shift. So the amp is going to be, well, the distance from here to here is 8. All right, the amplitude is a distance from the midline to the max or min. So my amp is 8. It's a positive cosine, looking at what it looks like. Frequency is 2 pi over the period, which is 12. That reduces to pi over 6. My shift is my midline, which is 22. So put it all together. Y equals 8 cosine pi over 6 t instead of x, because it's asking for t, plus 22. So it's pretty straightforward. The little picture is definitely helpful in helping get everything structured, so I want you doing that. Other than that, it's what we've been doing for the past couple weeks. I asked you number 4. Let's take a look at number 4 as well. Let's go a new color. I'm a little bored with these colors. Ooh, this one looks cool. Looks fun. All right. Aditya's dog Sparky eats leftovers, which vary seasonally. As a result, his weight fluctuates throughout the year. So does mine, by the way. The dog's weight, WT, as a function of time over the course of the year, can be modeled by a sinusoidal expression in the form. So it's telling you it's a cosine. At t equals 0, he's at his maximum weight of 10. So this is where my little picture comes into play. At time equals 0, where it's starting, he's at its maximum of 10. So at this point, because it's starting at the max, I know it's got to be a positive cosine. 6 months later, he's at his minimum weight of 6. So this is similar to the last problem. Since it took 6 months to get from the max to the min, that's half of a wave. It's going to be double that, 6 more months to get to the end. So I got a lot of information. I need the midline. My mid, again, is min plus max over 2, which is 6 plus 10 over 2, which is 16 over 2, which is 8. So looks like I can go by ones. So 1, 2, 3, 4, 5, 6, 8, 10. That's all I need to go up to. 4 dashes on my x-axis. 1, 2, 3, 4. The period goes at the end of the 4th dash. My midline is 8. Looking at my little picture, my max is 10, my min is 6. Now I'm going to draw my positive cosine, so I'm going to get a different color. And there it is. Now it's asking for the equation. Amp sign freak X shift. Amp sign freak X shift. Amp is the distance from the midline to the max or the midline to the min. It's the same value. It's 2. This is a positive cosine. Frequency is 2 pi over the period, which is 12, which reduces to pi over 6. Shift is 8. It wants a WT. Amp cosine freak. Instead of x, we have t in this example. Shift. And that's it. So pretty much same thing, and nothing new really for this next lesson, which it's just the same, it's the same lesson, it's just more examples. The Sea Dragon, a pendulum ride at an amusement park, moves back and forth from its starting position. The distance from its starting position can be modeled by a sine function, where t is the distance from the starting point. After 4 seconds, it's at its maximum distance, which is 8 feet. So the maximum it says is 8. Now, its starting position is going to be 0, being how the distance we're talking about is distance from its starting position. The distance from its starting position is going to be 0. It says it's at its maximum 4 seconds later, so to go from its starting point, and because it's starting at its minimum, because it's starting at starting point, which is 0 from its starting point, it's going to have to be a negative cosine. So because it's at its maximum 4 seconds later, the period is going to have to be double that to get back down to where it started, which is going to be 8. My midline is min plus max over 2. Which is 0 plus 8 over 2. 8 over 2, 4. Looks like my x-axis and my y-axis are kind of similar here. And a little typo here, it's not a sine function, it's a cosine function. So that's a little mistake, it should say cosine function. So I'm going to go by 1s, 2, 4, 6, 8, 4 dashes on my x-axis. Again, whenever you're doing trig graphs, sinusoidal functions, it's always 4 dashes. The period goes at the end of the 4th dash. Midline, min, max. Let's go yellow. Starts the min, then midline, then max, then midline, then min. There it is. If I want to write the equation, y equals amp sine freak x shift. My amplitude is the distance from the midline to the max, or the min, which is 4. This is a negative cosine. Frequency is 2 pi over the period, which is 2 pi over 8, which reduces to pi over 4. Shift is 4. Y equals negative 4 cosine pi over 4x plus 4. Lots of 4s in this example. And that's it. Again, it was a little tricky, I think, coming up with a little picture here, but its starting position, being how the y is the distance from the starting position, or whatever, t is the distance from its starting point, by definition, it's starting 0 from its starting point. That's why it's a negative cosine, and I think from there it comes together kind of nicely. Oh, this thing is huge. I'm going to skip 5, let you try that on your own. Let's take a look at 6 together. This is one that was on the regions. So this one was definitely a little tricky. This is actually a 6-point question on the regions. All right. The resting blood pressure, blah, 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 blah. It says to graph it. So, little picture is helpful. Let's get my little picture. My midline is 120. My amp is 24. So I'm doing 120 plus 24 and 120 minus 24. $144 and 96. Now I need my period. My period is 2 pi over the frequency. My frequency is between the cosine and the variable. So my frequency is 3 pi. So my period is 2/3. It's a positive cosine, so it starts at the max. And I have my little sketch. So here's the little twist. It's giving you a scale. So I can't just put 4 dashes and put my 2/3 at the end of the 4th dash. I have to put it here. So where's 2/3? Well, it's 1, 2, 3, 4, 5, 6 boxes to get to 1, which means that each box is 1/6. 2/3 is the same as 4/6. So this right here is 2/3. Now look, I got 1, 2, 3, 4 dashes, so it's really not that big of a deal. Now it doesn't specify a scale for your y. I'm gonna go by 5s, or you know what? I'm gonna go by, what about by 6s? Just so these end up being nice. I think I'm gonna go by 6s. So I'm gonna still label every other box. 102, 108, 114, 120, 126, 132, 138, 144, 150. So my midline is 120. My max is 144. My min is 96. Now again, my waves are kind of scrunched because it's ending here. So we're not going to be able to skip any boxes here, not a big deal. So again, it's starting at the max since it said it was a positive cosine. I'm not skipping anything because it needs it to be scrunched because it gave me the scale. Oops, that went a little bit off. I'll erase that in a moment. Now, because it said that it wanted me to graph it from 0 to 2, I need to keep on going. I need to make more waves. So I'm going to make, I have 4 more dashes, 1, 2, 3, 4, and I'm going to make another wave. Same wave, just going to make a second one. Midline, min, midline, max. I'm still not at 2 yet, so I'm going to do 1, 2, 3, 4 more. Max, midline, min, midline, max. And that's it. So I think this question was pretty simple in the fact that it gave you the equation. So the fact that it gave you the equation really should have made this whole process pretty simple. I didn't like how they forced a scale on you, so you couldn't just make your four dashes. You had to figure out where 2/3 would be, and then from there, because it wanted it from 0 to 2, you had to do a few extra waves. There's more. Determine the period. Well, we did already. We found the period is 2/3. Explain what this value represents in the context of the problem. So my period is 2/3. So period is your x value. Your x value here is t, which is time, and the unit is seconds. It takes 2/3 of a second. And what is this talking about? It's talking about the resting blood pressure of an adult patient. For what just happened? Oh no, did I freeze? Alright, hopefully that wasn't a big deal. Just had a little technical issues. Um, it takes 2/3 of a second. For the resting blood pressure. I'm going to say to return to its maximum. All right, now there's one more follow-up question. I'm just having some issues here with this thing. Let me try to pause it one more time. Oh, nope, here we go. Adults with normal blood pressure is 120/80. This means it oscillates between 120 and 80. Adults with high blood pressure is 140/90. Low blood pressure is 90/60. Classify the given patient's blood pressure as low, normal, or high. Well, we're going from 96 to 144. So 96 to 144 is above 140 over 90. It looks like we have high blood pressure. Because the range is 96 to 144. Sorry if it's a little sloppy, but a lot of stuff to put on this question. So a lot of follow-up questions. This was a little bit of a tricky question, but at the same time it wasn't, because it gave you the equation. This should have been pretty straightforward. There was the twist of the scale on the x-axis that we had to deal with, but not the end of the world. And that's it. So before this thing freezes, which I think it has again. Oh yeah, we're really frozen. Oh no, that's not going to be good at all. Alright, hopefully we're good. Let me just get back in here. This thing frozen. No. I think we're gonna. You know what we're gonna do? We're gonna try one more, and then I think after that, I'm gonna have you guys do the rest on your own. let me just make all this stuff a little bit smaller. In fact, let me move this to a new page. Ferris wheel questions, a lot of students have a lot of fun with. Hopefully you're going to enjoy it as well. You have to read carefully for all the important information. So let's kind of take a look at it together here. A carnival has a Ferris wheel that is 50 feet in diameter. So a lot of students get messed up with what that means. If it's 50 feet in diameter, that means from the max to the min is 50, which means the amplitude is 25 and 25. Hopefully that makes sense. The diameter is the distance from the maximum to the minimum, and if the diameter is 50, that means that the distance between the max and the min is 50, which makes the amplitude 25. When viewed from the side where passengers board, the Ferris wheel rotates counterclockwise and makes 2 full turns every minute. So they're boarding here. Are they boarding at the max, the min, or the mid? This is the midline, so I know it's going to start there. It's got to be a sign. Now it's rotating counterclockwise. If it's going counterclockwise, is it going up first or down first? Or counterclockwise is this way, it's going up first. That makes it a positive sign. So I'm going to fill that in. Now it makes 2 full turns every minute. That sounds a lot like period, but period isn't how long it takes to make 2 full turns, it's how long it takes to make 1 full turn. So if it makes 2 full turns every minute, then my period is half of a minute. Now it says that it wants it in seconds, so that makes my period 30. Again, if it makes 2 turns in 60 seconds, then it's 1 turn in 30. And that's what period is. It's how long it takes to complete 1 full cycle. Riders board the Ferris wheel from a platform that is 40 feet above the ground. So this right here is 40. If the amplitude is 25, then I'm going to add 25 and subtract 25 to find my max in my min. So again, it gave me the diameter is 50. That meant the distance from the max to the min was 50, which means the amp is 25. Now that I have the information that the midline is 40, I can add and subtract that from there. So let's do the equation first, just since I have space, and then I'll go to the graph. Y equals amp sine freq x shift my amp is 25. It's a positive sign. My frequency is 2 pi over the period, which is 2 pi over 30, which reduces to pi over 15. My shift is my midline, which is 40. So it's y equals 25 sine freq x shift. Now I'm going to just move this over. It wants me to graph it. The thing's going real slow. We did a lot of math on this thing. It wants me to graph it, so I'm just waiting for this thing to come up. Oh, hopefully this thing's still recording. So let's see where I'm at here. I'm like rolling the dice here. I really hope this thing doesn't freeze. I don't lose this whole 30 minutes of recording. That'll be really bad. So let's just snip that. Oh, wait, I didn't want that. Sorry. Being a little distracted here. I wanted this. So this is way too big. All right, let's get a nice color. Let's go stay purple. All right, and we're back. So I got my midline. I'm going up to 65. I'm going to go by fives. So this is going to be 10, 20, 30, 40, 50, 60, 70. So my midline is 40. My max is 65. My min is 15. 4 dashes, 1, 2, 3, 4. Period goes at the end of the 4th dash. It's a positive sign. So I start at the midline, and then I go up. Then I go midline, then I go min, then I go midline, and that's it. So you have to just read it carefully. Again, what important pieces of information were there that I needed? 2 full turns each minute leads me to the period. Again, period is how long it takes to make 1 full turn. So if it's 2 full turns, I'm going to cut that 60 seconds in half to 30. It says that they're boarding here. They're boarding at the midline, so that made it a sign. Made it start at the midline because it said it was going counterclockwise or going up first, which made it a positive sign. The diameter was 50 feet, so the diameter is the distance from the max to the min. The amplitude is half of that. That made the amplitude 25. So I added 25 and subtracted 25 to get the max and the min. And from there, I put it all together. So you've got definitely more examples here, but I want you to do it. I want you to practice. It's a little bit of, it could be a little tricky, but I want you to do it. And that's it. Your classwork/homework is to finish this. I'm going to give you 2 more days. Friday, we're going to do something new, but I'll make the quiz due Friday. So your classwork/homework for Wednesday and Thursday is to finish graphing sinusoidal models. Your quiz is going to be due Friday. I'm not going to put it up yet. I'm going to put it up tomorrow because I want you guys spending today practicing before you move on to the quiz. So I'm going to post it on Wednesday. That's the plan. Any questions, reach out to me on Remind. Again, I can graph sinusoidal models using amp, sine, freq, shift, and drawing a little picture. Have a great day.